Alright guys, in this video we're going to take a look at how to find the average atomic mass of an element. And you already have the idea of an isotope down. So isotopes are the different flavors, if you want to say it that way, or the different types of each element that exist, of each what's different about an isotope is that it just has a different number of neutrons. So let's take a look at an example of a moderately easy one. This is kind of in the middle range, because magnesium only has 3 naturally occurring isotopes. They are listed here. So magnesium 24, magnesium 25, and magnesium 26. And of course, we all know magnesium from the lab last week, or in the last couple weeks, where you burnt the magnesium. So it has that characteristic white flame. That's used in fireworks. Anytime you see that giant white flash or boom, that is magnesium. So let's get rid of our picture here so it's not distracting us, and let's talk about what's going on. It turns out that the actual isotopes themselves do not even quite add up to the atomic mass given for that isotope. And the reason is because of something called the mass defect. And it's complicated for now, but essentially in the nucleus, a tiny bit of energy, or a tiny bit of mass is converted into energy to hold the nucleus together. And that's where the equation E equals mc squared comes from. Or that's what that equation explains. So if this bothers you, that magnesium 24 has a mass of 23.985 AMU, we'll get to talk about it later why that is, but for now, that's where it comes from. So then, what I have here are the naturally occurring percentages for each isotope of magnesium. So you can see magnesium 24 is the predominant isotope, and then magnesium 25 is only 10%. Magnesium 26 is 11%. So if we had a bucket O magnesium atoms, there would be about 79 out of 100 would be magnesium 24, 10 out of the 100 would be magnesium 25, and 11 out of the 100 would be magnesium 26. So we're going to do what's called, to find the average atomic mass, we're going to do something called a weighted average. So average atomic mass is equal to, and now we're going to take the masses of each isotope, and we're going to multiply the mass by the percentage. So I'm going to take, and when you multiply by percentage, you need to move the decimal point, you need to divide by 100, so we're multiplying by 0.787 instead of 78.7, right? So that is the weighted average for the 24 isotopes, so then we do that same thing for the 25. We're going to multiply by 0.1013. And then we're going to add that one more. We got magnesium 26, which has an actual mass of 25.983. And we're going to multiply that by 0.1117. And we do that. And we just now in our calculator, we're going to take this multiplication plus this multiplication plus this multiplication, and do that in your calculator now. And you should get this number, 24.309, and of course that is atomic mass units. And what's interesting now is if we take a look at magnesium, we'll see that it actually has that mass. We can see here we put in the this is our calculated average atomic mass for magnesium, and if we look on the periodic table, we see it is 24.3. So, and we can ignore, significant digits explains the difference down here, but 24.3. So now you should be able to find the average atomic mass of any element on the periodic table. Woohoo!